Hey y'all. Today we're going to talk about the three type of functions we'll be learning in Math 1. As you can see, I have the essential question posted. What are some key similarities and differences between linear functions, exponential functions, and quadratic functions? Um, there are more type of functions, but we're only going to focus on three while we're in Math 1. So the three functions, again, that we'll learn in Math 1 are linear, exponential, and quadratic. So these are the three that we're going to focus on. And with these three functions, they can be represented in different ways or different forms. And we're going to go over those different forms that can be represented. And then in those representations, I'm going to give you key features that will allow you to determine what type of function it is. So the first type of representation we're going to deal with is graphically. So when we look at this one here, we can see, oh, sorry about that. We can clearly see that this is a straight line. Hence, it's what we call a linear function. So this is a linear function. This is probably the one that you are most common have seen 7th grade, 8th grade. A good thing to remember is line. And so if it is a straight line, it is what we call a linear function. The next type of graph is going to be one that looks like this. If it looks like this is what we call a hockey stick shape. I'm not sure if any of y'all have ever played hockey, but this is what a hockey stick looks like. So we call this a hockey stick. Whenever you see this shape, we call this an exponential function. So this is exponential. It exponentially grows. So it keeps growing. It keeps going up. That's why it's an exponential function. And the last type, as you remember, we said we're going to learn linear, exponential. So obviously the last one has to be what we call a quadratic. So this is a quadratic. And the key thing to remember about a quadratic is that it is a U shape. And this U shape does have a specific term for it. We call it a parabola. So the U shape is what we call a parabola. So this U shape that is formed from a quadratic is what we call a parabola. And understand that the parabola can be, it could be right side up, or it could also be upside down. As long as it has that U shape, it's a parabola, therefore it's a quadratic. So again, these are the three ways, the three functions represented graphically. As you can see, we have a straight line, we have an exponential or a hockey stick, and we have our quadratic, which is the U-shaped. So the next thing I want to talk about is when it's in table form. When we're looking at table form, we're looking at the pattern. And remember, we're talking about patterns in Unit 4, we always want to look at the Y value. So when I look at this Y value, is there a pattern going on? And hopefully you recognize there is. Each time we are adding 2. So from 5 to 7 plus 2. From 7 to 9 plus 2. From 9 to 11 plus 2. And hopefully from Unit 4 you remember that anytime we have a common difference, so if we're adding or subtracting the same number, that means that it is a linear function. So since we have a common difference, since we're adding and subtracting the same numbers, it is what we call to have a linear function. The next type of table that we're looking at, when we look at this one, to go from, we look at the Y values, remember we always look at the Y. When we look at 2 to 4, if we add 2 to that, we get 4. If we add 2 again, we don't get 8. 4 plus 2 is not 8. So therefore, we know that it's no common difference. But hopefully when you look at it, you can recognize that we can multiply 2 times 2, so multiplication, and we can do 4 times 2, will give us 8. We can do 8 times 2, will give us 16, and 16 times 2 will give us 32. So anytime it's multiplying, anytime we have a constant multiplier, keyword, vocab word, anytime we have a constant multiplier, it is what we call to be exponential. So anytime the pattern is multiplying, it is exponential. And so we have one more table. For all you who are smart like Sherlock Holmes, you probably recognize that this is going to be a quadratic. So for a quadratic, the key thing, the only thing we want you to look at right now is symmetry. All right. So our middle term or our middle coordinate, everything is going to be symmetrical about it. So if you notice, we have -1 and -1, and then we have -4 and -4. So we have symmetry about the coordinate that is in the middle. So if there's symmetry present, we just want you to recognize that it is what we call a quadratic. All right. And when we get to actual our quadratic unit, we'll talk about why this is true. But for now, we just want you to recognize that if there's symmetry, then it is a quadratic. All right, so we have one more type of representation left. This representation has an equation. Again, this formula should be very familiar for most of you. We have y equals mx plus b. So I'm sure everybody's shouting, that is linear. And it is. It's the one that you spent all the 7th grade and 8th grade learning. This is what we call slope intercept form. Slope intercept form. And there's another way we can represent linear functions. This might be new for you. It's what we call standard form. If you think about the box problem that's been in your warm-up for the past month, it has been given to you in standard form. So this is what we call standard form. Because remember, the box problem, you might have something like 3x plus 5y is equal to 20. This is standard form because we have our ax, we have our by, and we have our c. So standard form, ax plus by equals c, standard form. And we can go from standard to slope intercept or vice versa. So the base equation for an exponential is simply y equals ab to the x. So this is exponential. And the key thing to remember about this, anytime x is an exponent, so if x is an exponent, then it's going to be exponential. So only when x is the exponent. X is the exponent, then it's exponential. So if I gave you y equals 2 to the x, exponential. If I give you y equals 3 to the x minus 2, x is the exponent, exponential. So the last one has to be, that is correct, quadratic. So this one is a quadratic. So quadratic is in the format of y equals ax squared plus bx plus c. So anytime your highest exponent is a square, so anytime the highest exponent is a square or is a 2, so if 2 is highest degree, if 2 is highest degree, then it's going to be quadratic. Cool. So we have y equals 3x squared quadratic. We have y is equal to x squared plus 2x plus 8 quadratic. So anytime we have 2, and if it's the highest degree and there's nothing bigger than it, then it's going to be a quadratic. It's very important that you recognize these forms and you pay close attention to it. If you think back to when you were in kindergarten, you learned 3 major shapes. You learned circle, you learn triangle, and you learn square. And like you learned, square has 4 sides, triangle has 3, and circle is just a rounded shape. You learn those characteristics that you will recognize what they are. The same thing with a linear function, an exponential function, and a quadratic function. So in each representation, there are key characteristics that allow you to recognize what type of function it is. And it's your job to make sure you learn these characteristics that you can recognize these functions when they appear to you in different forms. Again, I hope this video helped. Please feel free to continue to look at it over and over again. If you feel as though you have everything down, that is wonderful. Y'all have a wonderful day.